that I've like written for, done all sorts of things. And he's like, so are you a homemaker? And I was like, no. Like, I was kind of mad. I was like, no. And then I realized I probably was. But I like to be a feral homemaker. That seems a little bit more fun.
Hey, Jaimi, do you mind if we record this?
Go for it. Yeah. This will be, but you never know with technology. So just like go for it. Yeah. So I can make my computer work. Throughout my presentation, there's going to be these QR codes, and you can just like take pictures of them and then go home and you can download this entire book, Great Salt Lake Biology at Terminal Lake in a Time of Change. If you would like to, it's 16 chapters and like hundreds of pages of like really in-depth science written by experts all around Great Salt Lake. A lot of those authors are from Utah State because Utah State is doing so much cool work on our, land, air, and water. So, and if these QR codes don't work for you, I'm happy to send anybody links. And I think really importantly right now is we're really like re-exploring water in Utah. And I could go back and I could like recreate this whole presentation, but actually Teresa Williamson is the state engineer. And if you go to this link that is the Great Salt Lake Summit, oh, you can't even see, it's like minute 13. I'll even tell you, like, you can skip ahead of all of the BS, like, and just like go to, it's actually minute 18. And she goes through Great Salt Lake's waterways in this way. Like, I've studied Great Salt Lake for over 24 years, and I've never seen such a like concise, clear, short overview of Utah's waterways and water flows that I highly encourage you to go look at, because gosh, it's so complicated. So here we are, we're, here's Bear Lake, right here, here's Great Salt Lake, I-15 would kind of run down here, Salt Lake would be right around here, Ogden, and you'll see, this is the Bear River watershed, the Weaver watershed, in purple, and the red is the Jordan River watershed. And all of these watersheds, they scour 22,000 square miles of land, and they deposit all of these minuscule amounts of minerals that come through these freshwater rivers, and they deposit that into Great Salt Lake. It's a terminal basin, so no water escapes Great Salt Lake. There's no outlet except through evaporation. So all of these minuscule amounts of minerals are coming through into Great Salt Lake, and they can't leave anyway unless we take them out. Mineral extraction takes them out, but the only thing that really leaves is water through evaporation, and everything else is concentrated. And, I like to point out that Great Salt Lake kind of has this memory, right, of what happened along all of these 22,000 square miles of watershed. And all of those things that don't happen along the way build up in Great Salt Lake. Great Salt Lake kind of has this memory that a lot of lakes don't have, right? Terminal basins are pretty special. I think this picture from the International Space Station, this Alexander Gerst, he takes amazing pictures of Great Salt Lake all the time. And I love watching him. And I love just this perspective of how big this place is on this planet. I mean, you can see it from space. It's incredibly big and also incredibly important. So I actually met the lake when I was here at Utah State. I got a fisheries management degree, and I always think it's really ironic. I got a fisheries degree and I work at a lake that doesn't have any fish in it. But I really did that because I love birds and I loved water, and particularly water bugs. And I quickly found myself working with the brine shrimp industry. And it was this really unique kind of man's world to work in, with this industry that takes brine shrimp, cysts, the eggs off of Great Salt Lake. They harvest from October until January, and it's a really hard job. Like, there are these people out on this stinky lake collecting these stinky eggs, living on the lake for weeks at a time. And the lake is not like a particularly friendly place that you always want to go to. It's very salty, the water is very dense when you're out on these boats. I mean, it will shake you apart when you go, when you're underway and you're kind of like rocking on those waves. Yeah, it's a pretty extreme place. And I quickly learned from all of these kind of shady characters, these brine shrimp harvesters, more about the lake than I could have ever imagined or learned. It kind of took this experience of being with the state. I cherish my time on Great Salt Lake, and I think that's one of my strengths, is that I've always been boots on the water, boots on the ground, like really working in the mud and in the salt. And these days are some of the funnest ones that I learned lots about the lake. And so there's a few things that we know and that we kind of have to understand about Great Salt Lake when we're thinking about what's going on. So Great Salt Lake is very segmented. Here you can see a railroad causeway. We'll talk about this in a minute. These are evaporation ponds. All of these segmented areas cut different parts of the lake off and prevent water flow. And it makes all of these different microenvironments that run from very super salty to freshwater and everything in between. So we have one of the most diverse ecosystems on the planet right in our backyard, from freshwater to the most salty water that you can ever have and anything in between. I do like to talk about this because, so here's Great Salt Lake, and originally our transcontinental railroad, you can go out to the Golden Spike National Historic Monument, that's like kind of over here. And just a background, I kind of have Salvador Dali geography, so if I say here, it means like somewhere in that vicinity. So there's the Golden Spike National Historic Monument 152 years ago. This railroad came, the west came from here, the east came from here, and we created the first transcontinental railroad. We did this huge thing that impacted the history of, I mean, the total trajectory of the United States, with this transcontinental railroad that could get things from the east to the west, could get people back and forth. But this was, you can see there's like lots of mountains. This is lots of space over here, lots of like miles. And see, this took lots and lots of, the trains had like lots and lots of fuel that they had to use to go all the way around north and all the way up and around all of these mountains. And so in the 1960s, we built this thing that's called the Loosen Cutoff. And the Loosen Cutoff went from Lakeside and straight across Great Salt Lake to Promontory Point. And then this is 12th Street in Ogden right here. And when we first built this causeway, it was pilings. Water would flow freely back and forth, but it wasn't very stable. I mean, the bed of Great Salt Lake is the bed of Lake Bonneville. Millions of years of like sediments and stuff is on the bottom. And the railroad causeway was very unstable. So we built, out of this, we ended up filling that causeway with rock and making it so that it was impermeable to water. So all of this water comes into here into the south arm of Great Salt Lake, but there's no fresh water going into the north arm of the lake. So here again, 12th Street in Ogden north is pretty much cut off from fresh water. So it's a very unique place. I love this story that the state historic preservation officer told me about this. So this is on my way to Spiral Jetty. And when you're going out to Spiral Jetty, you find the road kind of comes right along here. And when you're out there, you can see these like really like distinct places. And I love this story because what happened is the railroad, they didn't have a plan. So they knew they were going to meet somewhere around somewhere at some time that nobody really knew about, and there was no plan. And so because these railroad workers and railroads were making money built on how many miles of railroad they laid, they just kept going. And so in some places, you can actually see, oops, I forgot, I have to do it this way. You can actually see where these railroad where the railroad workers crossed. They were like within a stone's throw of each other, and they built 60 miles of track side by side going different directions because there was no plan in place. And I just always have loved that story. And you can see that on the way to Spiral Jetty. If anybody wants to go to Spiral Jetty, come ask me afterwards because it's a must do. And so looking, from above, we have, so again, here's Salt Lake, here's Weber County, here's 12th Street, here's that railroad causeway. All of the fresh water is coming into. So we have this great salty lake that has different salt contents in different areas. Gunnison Bay, or the North Arm, is saturated with salt. So, 30% of any given water is salt in the North Arm. When it gets cold, the salt falls out onto the bed of Great Salt Lake. Some parts of this area have over 11 feet of salt on the bed of Great Salt Lake. So, huge salt deposits there. Okay, but fresh water comes into here. Fresh water comes in from the Bear River, the Weber River, the Jordan River. Gilbert Bay is about 12 to 16% salt content. Now you're going to hear different numbers. Like if you're listening in the news, you might hear 120 grams per liter, or you might hear 160 grams per liter. I just want you to, that 120 grams per liter means 12% salt content, 160 grams equals 16% salinity. I put 12 to 16% up here because there's a Salinity Advisory Council that has done tons and tons of work. Amazing amounts of the nerdiest in-depth science that you can ever imagine to determine that the optimal salinity for the South Arm of Gilbert Bay of Great Salt Lake is 12 to 16%. Right. And I think that's important to know that the lake is really evolved in this very dynamic state of lake levels going up, salt content going down at the same time, lake levels going down and concentrating salt. So we have this range that's very normal for Great Salt Lake, and that our cool Great Salt Lake bugs and microorganisms can live in. And so I put 12 to 16 as optimal salt content. And then we have Farmington Bay. Farmington Bay is kind of an interesting thing because that's where all of our municipal waste from the Wasatch Front goes. So everything that goes through our sewage system ends up in Farmington Bay, which is weird, right? Except for we save a lot of money because we don't have to clean our water to pure. Our water is going into a salty lake that we don't drink. We're not eating fish out of that lake. And so we can save money by not cleaning our water to pure. It causes some weird things in there. There's lots of nutrients, and that's probably most of Great Salt Lake smell comes from all of these nutrients that spur growth. And then there's all of these bugs or microorganisms that die off, and when they decompose, they smell. So probably most of that yummy Great Salt Lake stink that everybody talks about is coming from Farmington Bay. And please, this is a small group, so it very informal, yell out questions, very friendly. Okay, so we know that Great Salt Lake is segmented. We have all of these microenvironments. Great Salt Lake is also super shallow. So at greatest depth is somewhere between 30 feet or 10 meters. on average, at average surface elevations, that I think the average depth is somewhere around 11 feet. So it's this very shallow basin. That means like more water is exposed to the air, and it's very easy to, it's very quick to evaporate in our hot summer times. And you'll hear a lot of people talking about evaporation rates off of Great Salt Lake because it is very big. And, you know, this is very different from places like Bear Lake, that's very deep, or Pyramid Lake, that's another salt lake, or Mono Lake, that are deeper and have a little bit of more protection from that water loss and evaporation. So we know that Great Salt Lake is segmented. We know that it's shallow. And I bet you might have heard that it's shrinking. It's been like all over the news. It's all I can do to keep up with it. And I mean, again, Great Salt Lake is super dynamic, right? This is like lake elevation that's on the side here, and these are years we've been watching Great Salt Lake since pre-1900. The Mormon pioneers started keeping track of it, and you can see up and down, up and down, up and down. Currently, though, you know, from 1980 on, we've seen this really high in 1986. That's when I met Great Salt Lake. I was like standing on the shore at the south end, down by I-80. And like, I mean, you can't even imagine it now, but we were sitting there and like plunking rocks into the water. We didn't have to throw rocks. Like the water was lapping up on I-80. So very different in the 80s. And since then, we can see, I mean, the lake is just steadily shrinking. You know, you don't have to know statistics or listen to Wayne Wurtzbaugh from Utah State to know. I mean, you can see right here how much Great Salt Lake is shrinking. And this, I would, you know, really say is kind of three factors. Is drought. We've been in a drought for the past 20 years. It's the biggest drought. It's a mega drought. We haven't seen that in over 1,200 years, a scale of drought like this. We are diverting lots of water. There's, you know, 2.5, 3 million humans that's really reliant, I mean, just along the Wasatch Front alone. And we're starting to see this climate variability that comes with climate change, and more people, right? More people, more diversions. And so what happens to this Great Salt Lake ecosystem? How does this shrinking lake affect this ecosystem? So there's really two weakly linked food chains. There's one based on brine shrimp. They're my favorite. They were my first love at Great Salt Lake. I know it's very silly and very nerdy. These brine shrimp are sexually reproducing. So these are males. Males have these big claspers, and they don't normally look like that when they're alive. They look like Santa Claus. They look like they have a beard underneath them, and they use those claspers to hold on to the female. The female has a brood sac. They eat microorganisms, very tiny microscopic organisms that are in the water, that mostly hang out in the water column is where brine shrimp are really hanging out. And then the birds that rely on them, these are my favorite birds. Eared grebes, I started studying them when I was here at Utah State. We wanted to know if eared grebes, if brine shrimp harvesters were leaving enough brine shrimp for the eared grebes to eat, because eared grebes come to Great Salt Lake, they lose their feathers, they molt, and they just gorge on brine shrimp, and they get so fat that they can't fly anymore. And they just have to dive and dive and dive. They eat 20 to 30,000 brine shrimp every single day that they're on Great Salt Lake while they're foraging, and they pick them out. They're not like a whale that has like baleen that they can scoop out. They pick individual shrimp out of the water one by one. They have to catch 2 shrimp every second that they're feeding. So really important. We'll talk a little bit more about eared grebes later, but brine shrimp are pretty cool because they lay these dormant cysts. They have 2 ways of reproducing. They can either release live young into the environment. So if it's really awesome outside and they're like, oh, my kids are going to survive, like my offspring, they like have enough food, like everything seems good, they release these live young that can just like very quickly grow into reproductive age and reproduce. But they also have these dormant cysts. And these cysts are kind of like I've always called them kind of like an M&M, because they're like a little embryonic center with a hard outside shell that's like very, it can withstand heat, it can be desiccated, I mean, all sorts of things. And it actually goes into this dormant stage. So these cysts, they're released in the fall, and they're just kind of hanging out on Great Salt Lake, but they're in this dormant stage. And they have to go through a cold spell. They have to go through a cold winter so that they can hatch again come the springtime, which is pretty cool, right? Because something kind of goes wacky in the environment, they have this way of insisting themselves and almost becoming, it's like a little time capsule, is kind of how I've always thought about these brine shrimp cysts. People do harvest. I've talked about this a little bit. You can see this is a boat. If this boat is like 70 feet long and it's on Great Salt Lake, this is a streak of cysts. And so these are all eggs that are like the size of like a grain of sand. And they congregate in these currents, depending on what the lake is doing, that look like an oil streak. And actually, the brine shrimp harvesters use the same technology as people that are skimming oil spills. They use oil containment boom. I mean, the same technology is used for Great Salt Lake. And, I found this like really lively community of people that was actually really working together for a sustainable Great Salt Lake, in particular, a sustainable Great Salt Lake brine shrimp harvest, because their livelihood depended on it, these groups depended on it. And so people really they really came together in like really the mid 1990s, started coming together. Brine shrimp harvesters thought that they were over harvesting and actually asked the state of Utah, like an industry came to the state of Utah and said, hey, can you please manage us? Like, we think that we're over harvesting. And I mean, I think it's such a great model, because I haven't heard of very many places that this.
What did they do with the brine?
Oh, thank you for asking that. I always skip over that part. So they use brine shrimp. The cysts are sent around the world. They're dried and disinfected, and you put them in coffee cans, and they kind of look like a coffee can. They're a shrimp can, and they're sent around the world and used in commercial aquaculture. So 60% of the marine finfish that we eat, or the marine fish that we eat, are fed baby brine shrimp in their early stages. So this is important, right? In like global human food stability is this aquaculture, this fishery that provides us with food for aquaculture. A lot of these fish will eat anything, but lots of them, they need these baby brine shrimp. So they take these cysts, they put them in seawater, and then they hatch them out. It takes 24 hours, and then there's little baby brine shrimp that swim around, and those fish like to go after those, they like to catch them, they're kind of like a little movement that they can catch, and they're really nutritious. So after these brine shrimpers raised their hands and they're like, hey, could you manage us? They did. They came up with this like really cool program called Great Salt Lake Ecosystem Program that you can read out here. I know you can't see it very good, the citations here, but this is a peer-reviewed paper where the state is talking about how they are adaptively managing this brine shrimp harvest for both humans and birds. And they have all of these different sample sites all across the lake. It was really fun to be in a boat across, in the winter time, the state is going out twice a week. And this is like no small feat. This is like 75 miles of Great Salt Lake salt with a boat, kind of dangerous. It can be pretty precarious. And this happens twice a week during the harvest season until January, until they stop the harvest. They manage, so I told you they manage adaptively based on what's left in Great Salt Lake. So they don't, the state managers don't say, hey, you can harvest 100 million pounds. They actually say you have to leave 21 cysts per liter of water in Great Salt Lake based on all of these different sampling locations. So pretty cool, right? Because if there's not a lot of shrimp in Great Salt Lake, they can cut the harvest off and they can say, no more harvesting, we're leaving that so it repopulates in the springtime. They've extended the season even. If there's too much left in Great Salt Lake, they've extended the season. So a pretty cool adaptive management plan that GASP is like kind of progressive for Utah. I mean, it really was, I don't know who got this set. What it means though, oh, my numbers are all cut off. I'm really sorry. But what it means, this is the raw harvest pounds of brine shrimp cysts that have been harvested since 1990. And the important thing is watching just this trend line. Like we do have some dips and we do have like ups and downs, but overall, since we've really figured out this management scheme, there's this upward trend. I mean, all the way up to 47 million pounds was harvested in 2019. The average is about 35 million pounds. This is $50 to $60 million a year for the state of Utah. And it turns out because of our management scheme, we've actually optimized brine shrimp populations in Great Salt Lake. Like we harvest them, people take all of these cysts off of Great Salt Lake. And at the same time, we've optimized brine shrimp populations in the lake. Brine shrimp, super prolific, my favorite number. Sometimes in Great Salt Lake, in the middle of the summer, at peak brine shrimp density, there can be the same amount of biomass in brine shrimp as the biomass in 1.8 million people at one time. Like not just over the summer, like 1.8 million people being in Great Salt Lake at one time. That's essentially 2.5 million people are along the Wasatch Front. So imagine the Wasatch, I mean, that's like huge, that just to kind of put that into perspective. And then here's my little friend, ear grebe. They have these beautiful red eyes and they have these ears during their breeding season. And 5 million of them. This is over 95% of the world's population of eared grebes that comes to Great Salt Lake every year. They lose their feathers and they can't go anywhere else and they need something to eat. So this is one of those species that folks are getting really worried about, and we can talk about those later. There are so many eared grebes that sometimes the weather people will say, hey, did you see the birds migrating out of Great Salt Lake? And if it's like right around Thanksgiving time, you'll see millions of them taking off of the lake all at one time on these on weather radar.
And where are they going to?
So they're going south. We don't always know like where they're going. Most of them are kind of hanging out like Mexico area. There's another species of bird I'm not going to talk about today very much. They go all the way to Argentina. So I always think about Great Salt Lake as being like a gas station along this like string of gas stations that you have to get to the next gas station or you can't go anymore. And Great Salt Lake is an enormous hub for 10 million birds, 338 species that come here to rest and refuel. Okay, so brine shrimp, they're kind of one arm or one of the parts of that loosely linked food chain. And then the next are called microbialites and brine flies. People used to call these microbialites, you might hear them called bioherms or stromatolites. We don't need to get in, I call them microbialites, and we can talk about why later, but these microbialites are this complex community of microorganisms that actually, so there's this biology, these microorganisms, and they photosynthesize. And when they photosynthesize, so they need the sun, and they're green, and they photosynthesize, and they change the pH of the water. So they do this chemistry, this biology does this chemistry. And when they do this chemistry, change the pH of the water, it actually lets minerals precipitate out and creates reefs that are called microbialites. And so it's kind of hard to see here, but there's like this fuzzy living section, and then there's like rock underneath here. Well, these brine flies actually pupate. Their little caterpillar stage lives on the bed of the lake on those microbialites, and they eat, and then they pupate. They have their cocoon that's called a pupacase, and they hang on to these like rocky structures that are on the bed of Great Salt Lake. These flies are pretty cool because their larva lives through the winter. So you even in like, I mean, it's below freezing out there. This February was the coldest Great Salt Lake on record. I mean, it's below freezing, and they have this antifreeze in their little squirmy wormy bodies that helps that allows them to stay alive and to move, and actually feeds a lot of these overwintering waterfowl like common goldeneye and northern shoveler and green-winged teal. And this is a really, really important part of these overwintering waterfowl because they don't have food other places. Everything is frozen. I mean, you know, they can't even get to the bottom of a lot of places because there's ice on top of them. And so there's this brine fly food chain. There's the brine shrimp and then the brine fly food chain. I just wanted to give you an idea of the extent of these microbialites. This is in this like neon green. You'll see they're kind of like all along scattered the edges of Great Salt Lake. These are the kind of peripheral edges of the lake that are shallow. And so sunlight can penetrate down onto these microbialites so that they can photosynthesize. These microbialites, like they don't look, I mean, what do you think? That's maybe 10% of the area, thinking about the south arm of Great Salt Lake, like 10% of the area. These microbialites and the microorganisms that are associated with them are really, they're really 30% of the primary productivity of the lake is estimated. Studies are still happening on like what the reality is, but like 30% of the sun's energy that's making food is going into these microbialites. So they are super duper duper important for Great Salt Lake and the ecosystem of Great Salt Lake.
How are the microbialites different on the north arm than the south?
That's a good question, because remember this is saturated, so like they're like, it's so salty that these microbialites can't live. So all of these we know are dead. And they have, like, we've kind of thought about them as an apartment building. So these apartment buildings, like they're still actively being built upon. These ones have living organisms on them, but they're not building them. They're just kind of like this static apartment building.
And there's no brine shrimp.
And there's, well, see, that's tricky. Now you're talking to a scientist and you're talking like, there's like these special north arm shrimp. But there, you do see north arm shrimp up here. I don't think they're washing through here either because they're small and they don't reproduce and they look totally different. So they're like these like super extreme shrimp, but they don't reproduce because they really are very physiologically
And
stressed.
why is that north arm pink?
That north arm is pink because the only thing that can live in it are these microorganisms that are generally colored pink or orange or yellow to protect their cells. So they're like trying to keep out that sun, keep out all of these things. So they have pigments like not chlorophylls, carotenoids or xanthophylls that are red. And so if you go to Spiral Jetty, it's like, I mean, have you all been to Spiral Jetty?
The first time last October.
And what did you see?
Well, we had to walk quite a ways from Spiral Jetty to get to the water,
Mm-hmm.
but it was ethereal, just another world, and that pink color was really incredible.
Because people kept telling me, they'd be like, okay, so the north arm is like pink lemonade, and these are brine shrimp harvesters, and I'd be like, yeah, right, whatever. And then I went up there, there's actually, so this, and well, I think it's coming up here, but this area is at 12 to 16% salt content, and this is like 30-ish, something like that. There's a causeway in between here, and we'd have to take our boats through there. So this is twice as salty up here. and you would go through the culvert and your boat would rise out of the water and it would like kind of feel a little bit tippy. Like you're in these big aluminum boats and I didn't like it very much. It was kind of scary up there. Yeah. So there are some shrimp. We won't talk about it very much, but this right here, Amy's here. She like lives, eats, and breeds pelicans right now with her PhD dissertation. This right here used to be an island. It's called Gunnison Island. It's one of the world's largest breeding grounds of American white pelicans in the entire world. Something like 20% of pelicans in the United States come off of this island or born on this island. You can see it's no longer an island now, which has impacts on those pelicans. So if you're thinking about the North Arm, there's lots of pelicans, lots of microorganisms. NASA studies the shorelines of Great Salt Lake because they're like a model for what is on Mars. So same things that are found on the shorelines of Great Salt Lake in the North Arm are found on Mars, salt and gypsum crystals. So there's some pretty cool things up there.
So predators can get to those birds now.
Yeah, and people, I would say people are, there's coyotes on the island, and we know that you can look at the Pelicams as one of the projects we started at Westminster, where there's motion activated cameras on Gunnison Island to detect predators. We know there's red fox, we know there's coyotes, we've seen humans out there, and even if those predators like humans or coyotes aren't eating the baby pelicans, we did see some predation, but mostly they're probably just harassing them. And those big parents, instead of staying with their babies and sitting on their nests and sitting on their eggs, they take off if they're scared by something, and their eggs are vulnerable to predators. Like the biggest predator out there actually on pelicans is gulls. The gulls will eat the little babies until they get a certain size, and especially the eggs. So like those parents just being harassed by a coyote is very important. It's very detrimental to them.
One more question about the North Arm.
Yeah, please.
Did those microorganisms involved when they put the causeway across? Like how, it's been like in our lifetime that we get this.
I know. So there's been some really interesting work because there's all these birds, and all of these birds are like flying, they're migrating, they're like going to they're not just coming to Great Salt Lake like on their way like south or north, but it's kind of this like regional hub for all of these birds that might be at Yellowstone Lake or that might be in Nevada or that might go to Bear Lake, so it's this like big hub. And it turns out when birds migrate, like they're not perfectly like sterile and clean, and they can have microorganisms like on their bodies. And so we don't know totally. It's such a good question. We do know that birds can spread microorganisms. We've like seen that on Gunnison Island when we cultured like feathers of birds, we could see that. And we know that they can be airborne also. But typically, like super hypersaline lakes, they have very similar microorganisms that live in them. They have the same shape, they kind of have the same function, like, yeah, weird. And, this is just a really good look at, this is exactly the same location that we sampled in 2021 in July versus September of 2021. And you can see just how far in a dry, hot summer with no precipitation, how far that water can recede. And it exposes these microbialites. And you can see, they look a lot different. Like there's not fuzzy, gunky stuff on the top of it that's productive. These are bleached and dry, and the flies are really not doing very awesome right now. And these flies, they feed entire species of birds, not just during their time when they're on the land, but also when they're in the water as pupa. And I do have to say something, people always get brine flies mixed up with no-see-ums. So brine flies, like you always hear, like in the spring, the bugs will eat you alive at Antelope Island. And I've done that. Don't go out in the spring from April until July. Don't go out. The flies are not like that. Flies do not bite. They kind of stay like, I mean, they look like you're rolling a carpet. When you roll a carpet up, you can kind of like follow them, and they just stay very low to the ground. And the gulls, they cut their wings and they just they do that. They don't even have to catch the flies. They just funnel them right into their mouth with their wings. And then this is this year. And you can see, before you had these like really beautiful kind of round structures. They do that, they grow towards the sun, like they're trying to reach like the sun. You can see how they've caved in and are really no longer functional right now. And so the cool thing is, like we're kind of watching this, a lot of people are watching this and have been working on this. And one of the great things is there's this Great Salt Lake Advisory Council, and the Great Salt Lake Advisory Council consists of managers and other stakeholders, including like scientists and conservation groups, industry. And so this Great Salt Lake Advisory Council, they were like, okay, wait, we're starting to see lake levels recede, and we really need to understand like how that's going to impact the biology of Great Salt Lake. And so they made this really big like matrix that's kind of confusing. And I don't want to get too stuck in things, but here you can see green means good, I can live, we don't, like, it's not really optimal. Red means that like crossed this threshold for whatever it was. So there's bacteria. This is the archaea that lives in the North Arm of Great Salt Lake. They really, really, really love high salt content. And then you'll see, let's see, here's brine shrimp right here. They like do pretty good. This is that like 12 to 16% in here. And not so good after that. Right now, this year, we reached a very historic elevation low at Great Salt Lake. And if you look at this is 19% salt content is where we reached, because that salt concentrated so much. Brine shrimp, really live in this like 12 to 16% range. And so a lot of these organisms, right, here's like algae, here's brine shrimp, here's the flies. I don't know why this isn't red. They actually like taper quite a bit off. They don't reproduce after this. So we have like some of the, we're getting into this area where we're reaching a tipping point in terms of salt content and in terms of habitat availability, right? Because those microbialites have been desiccated, right? They're exposed because, there's no water. And so what are the impacts of these? And we could dive into the nerdiest, like most specific details ever, and I'm not going to do that. But the microbes are already being impacted. We're seeing species shift across the lake, not just in the North Arm, right? We've seen that in the North Arm. It's now pink, only, these extreme halophiles can live in there. Microbialites have bleached. Remember, that's 30% of the primary productivity on Great Salt Lake. And shrimp, shrimp are they're interesting in that they like different microorganisms at different times of the year. And so those species compositions are changing and changing how brine shrimp are living. The bugs are impacted, and I don't say bugs meaning like the true sense of bugs, just like creepy crawly things like shrimp and flies. We know that those are being impacted. So the microbial food source changes, there's habitat loss, so there's no longer those reefs for those flies to hang on to and for them to eat. There's The brine shrimp are starting to behave a little bit different. Brine shrimp have a higher tolerance for salt than the microbialites do. So the microbialites and this fly part of the food chain are really the part that we've seen this year being impacted.
How long does it take microbialites?
Oh, that's such a good question. We don't know. So we don't know, but there's a person named Carrie France at Weber State who has been really starting to look at that. And so originally when she started working, everybody got really worried because they were like, so these might take like decades to regrow. We don't even know. So some of their like kind of beta test experiments that are going on now, taking dried microbialites and putting them in the lab and seeing if they grow, they are tending to grow pretty quicker than we thought. So that's really good. Because people were like, oh, well, we could take those microbialites and we can move them to deeper parts of Great Salt Lake. And I mean, when you look at the extent, like if you go in a plane, the extent of these microbialites is huge. And you can't just like, you don't just like take them and move them like a piece of furniture. They're like really delicate and they kind of fall apart. And they're, I mean, that's not really feasible. So hopefully they return quicker, but that's still to be determined. People are still looking at that.
I have a question. Is the salt content getting larger because the amount of water that is treated?
Mm-hmm. Exactly. So there's not as much fresh water. And so those minerals, because they don't go anywhere unless we take them out, like evaporation ponds do, or evaporation companies, mostly they just stay there. But then the water leaves and they're concentrated. So birds are being impacted. So not only is their diet threatened, but also their feeding grounds and their isolation to these islands, like our pelicans that trade food and fresh water for a safe place for their young. They don't really have that anymore. And we are starting to see impacts on where birds are going and populations. And humans. I mean, we're all of these humans that are living here that stand to be impacted. Our economy, the lake is worth $2.2 billion. There's lots of jobs that are associated with that. There's lots of recreation, you know, Great Salt Lake contributes to like skiing. It falls in the mountains and ends up in our reservoirs and we go boating on them. And a shrinking Great Salt Lake hugely affects air quality because all of that lake bed that is exposed that has millions of years of stuff on the bottom of that. Some of it has been accumulated by humans putting stuff in Great Salt Lake, but also just naturally out of the ecosystem, arsenic comes down, you know, through all of those waterways and concentrates in the lake. And all of those exposed lake bed gets blown up by these storms that we get. So air quality is going to be huge. There's cost of recreations. You know, Owens Lake is a lake that we dried up. We took all of the water and so we took all the fresh water and we sent it to the city of LA for the city of LA to grow. And we dried Owens Lake up. And we could talk about Owens Lake for a long time, but thinking about 15% of everybody's water bill in the city of LA goes to fixing Owens Lake. And that essentially means they've like put 2-inch gravel across the entire lake bed. They've done some other things like sprinkling and wetting down some of like freshwater bird areas, but 15% of their water bills go to Owens Lake, and that's over $2 billion as of now to keep the dust from flying off of the lake bed of Owens Lake. And you know, these lakes like Owens Lake or the RLC that have been desiccated, I mean, we can go to those, we can look at, you know, the negative human health effects, we can look at all of these things, right? But really, like, Great Salt Lake has 2.5 million people living right on its shore. Owens Lake was dried up when there weren't very many people, and it's essentially a ghost town. There's not that many people there. So there's going to be these human health costs. I mean, not just the health effects of lung cancers and respiratory diseases. Like there's this cost that goes with that. And I would say, I mean, there's a cultural loss, right? We will have an environmental disaster in our backyard to leave to our kids that to me is, I mean, we can talk about birds and economy, but that cultural loss of like our namesake and just having that environmental disaster in our backyard, I think is huge.
Owens Lake is so much littler than Franklin.
And what?
It's so much smaller.
Mhm.
Owens Lake was.
Oh yeah, thank you. Owens Lake is 110 square miles. Great Salt Lake, the footbed is 1,700 square miles. So like the magnitude, and there's differences depending on like what the substrate of the lake is. You know, people have looked at that, but totally right. I brought Carrie so she could like fill in all of my blanks. And so we're all here, you know, because we're in this Great Salt Lake pickle. I called, you know, I feel like it's this Great Salt Lake pickle. And so, you know, gosh, what do we do? I mean, people are starting to realize this. And I've worked out here since 1999 is when I really started working on Great Salt Lake. And never did I ever see as many articles, as much attention as I've seen lately about nuclear bombs, terrifying prospects. You know, there's a lot of like news organizations that are collaborating together and sharing information. New organizations like Save Our Great Salt Lake have come up. I mean, it's like, I don't even work and I can't keep up with all of the articles on Great Salt Lake. Even if I wanted to right now, I couldn't. These kids are their sixth grade class and they're trying to get brine shrimp listed as the official Utah state crustacean. So I think that if you're like looking at any bills this year, House Bill 137 is the state crustacean designation. We should all write our senators because it's going to the Senate floor sometime in the next 2 days. We've had academics that are writing about emergency measures. I mean, like this, has this ever happened. This is a report that was written by academics from Westminster and BYU and lots of places. This is like a whole list of names about what emergency measures need to happen. And scientists usually don't like go outside of our box when we're like thinking about what, you know, solutions for this thing. Normally we're like, hey, we observe this, and I think a lot of scientists felt this responsibility to say, hey, like our lake is literally in active collapse this year. It is like it's like at that tipping point and pushed to like write this big emergency measures paper. People got their knickers all in a knot because scientists went outside of their box. And I mean, it's like this very like volatile political situation now. We know from USU, Joanna Enterwada and Karen Kettenring from USU have a survey out about what people are willing to do to help Great Salt Lake. People are concerned about it. I mean, I could go on and on and on. So then we really want to think about solutions, right? And that's where I'm a scientist. I know that the pelicans are not doing very good. Because, you know, coyotes are getting onto their island and they're not able to reproduce. I can watch like these flies, like actively like dying. I see birds not being able to feed where they normally used to feed. I know from my time working like with the brine shrimp industry that after 18% salt content, brine shrimp don't reproduce. Remember, we hit 19% this fall. So then I'm like, well, what do we do? What do we do? And I feel like I'm a little outside of my lane. And so I think these are some solutions that I've seen that have really like helped Great Salt Lake right now. One of them is just folks from the media that are working together as this collaborative to share stories, not reinvent wheels. The Deseret News shares stories with the Salt Lake Tribune. They can print these stories. I mean, it's been this like really cool way to get information out to the public. I'm glad we got Bagley to make a shrimp cartoon. Or my other favorite one that he has, I need to put this up here. It says crickets make me barf. And it's a picture of a gull flying. It was one of the 2000, it was made during the 2002 Olympics, I think, one of those like funny pins. I think that is a huge thing because, I grew up here. I grew up in a place of apathy and disdain. The lake had bugs. It was stinky. We didn't go there. Everything was dead. And then, I started working out there and I was like, oh my gosh, like there's this untold story about all of these birds, about all of this like cultural like stuff that's going out there, this economy. And so I think this is a huge one. The Kem Gardner Policy Institute at Utah State, they just announced the Great Salt Lake Strike Force. And we can look at all of these one by one, but these are the recommendations. Conservation. So commit conserved water. So these are their recommendations. These are their policy options that they're giving to lawmakers to say, like, these are the things that are actually feasible. So conservation, optimize agricultural water, optimize municipal and industrial water use, limit water growth, right? We can't keep growing. We get like there's so many more people here. I mean, we can't just keep using how much water we're using both in agriculture and in our cities. Water banking and water leasing. They put active forest management because somebody came up with this idea that we could like cut down forests and save Great Salt Lake. So that like isn't really, we could talk about that too, but optimize mineral extraction. We can find new water. Like what if we could import water from the Pacific Ocean? Wouldn't that be cool? We could like cloud seed. These are all these options that they have. There's also engineering solutions. So we could raise this causeway berm. We'll talk about that. And we could also mitigate dust hotspots. One of the big things is dust, right? And so we know where these hotspots of dust are coming from, and we can somehow mitigate that. Probably in an Owens Lake situation, put 2-inch gravel across these places, or maybe put sprinklers on the bed of the lake to keep them a little bit wet. So these are kind of the options they have. I just wanted to kind of bring attention. So each one of these in this report that you can find at this QR code, each one of these has a scorecard. And I think that's pretty cool, right? And so I wanted to talk about this raising and lowering the causeway berm. And I wanted to show you these are the scorecard results. So you can't see them very well, but essentially each one of these has a scorecard that's like, what are the benefits? What's the feasibility? What is the challenges with that? And each of these are kind of scored on all of these. One of the things that's really cool. So, did I do another one? Uh-oh. I think my computer. Okay, here we go. I think I put like 3 extra slides of the same slide in. So raising this causeway berm. So this is the railroad causeway that goes, here's the south arm, here's where all of our shrimp are, here's the pink water where the pelicans live. There's a breach in this causeway. There's this culvert that lets water from the south and the north flow back and forth. And so what we've realized over the years by studying this is that this can be used, this railroad causeway that we just kind of willy-nilly put in the lake without too much thought about the environment, could actually be used as a management tool. And at the time when we were talking about this, there were no other solutions for decreasing the salt content in Great Salt Lake. So remember, the two issues we're having are habitat loss and increased salinity. And so what we can do is we can close this berm off and make it so that all of the fresh water stays in the south arm of Great Salt Lake. So instead of going and flooding all into this north arm that's already saturated, that's already dead, we could keep that fresh water in here and decrease the salt content of the lake. Also, if this gets too, if this gets like less salty than we want it, that's in that optimal range, then we can open that berm and we can let that water go into the north arm. And that also takes salt with it. So we have this, like, it's kind of like a slow moving adaptive management that can happen out of this berm. And this, I think, is like a success story right here. Like, it seems really weird, it seems counterintuitive, but it really is the only way that right now we have to manage salt content in the body of Great Salt Lake. So,
Normalized the salt.
so this salt will never be normalized.
How much is that?
So this, well,
Decreases salinity.
so every year the lake goes up, 3 feet or so, and depending on evaporation, goes down 3 feet. Right now, what we've seen, actually, I have a graph. So remember, I showed you that this was in November. This is like the highest salt content that we've ever seen in the south arm of Great Salt Lake, the lowest lake level, all the salts were concentrated. Through the winter, we have had about an increase of about 1.5 feet. We closed the causeway berm, and as of today, it was about 16.5% salinity. So, we're still a little bit over that optimal salinity, but we're also waiting for all of this snow to melt. We're seeing some like good signs that, this is actually working. And so I hope you didn't come here like hoping to talk about like House Bill 244, or I can like answer questions about those. But as I was preparing this talk, I really felt like that there were bigger things than just like House Bill 244. That like the bottom line is right now we're at an emergency. I see 2 time frames for Great Salt Lake. There's this emergency time frame where like the ecosystem is like in active collapse right now. And we just need to get wet water to Great Salt Lake, whatever we can, in an emergency style way. And it's easy, but everybody just needs to do everything. We all need to conserve water, be it like as farmers, be it as like in our cities, however it is, everybody needs to do everything. And I don't want to say that flippantly, because I feel like I'm not the solution person, right? I'm a scientist that knows like what's happening in the ecosystem. And at this point, we've waited so long that we all just need to do everything.
Does the Bear River actually get to the Great Salt Lake?
Sometimes. Well, it didn't this fall. We went out on a flight and you could see it go through like Bear River Bay and then just kind of like stop. Yeah. I think nothing's impossible. We built a causeway that split the lake in half. That's a huge like engineering feat. We like built this railroad that went from like the east to the west. Before we even had the technology that we have now. We have this very resilient ecosystem, and I don't think anything is impossible. And I think the biggest thing is like, we just need to work together. We're seeing these successes in the watershed, kind of like the brine shrimp industry that was very successful, the optimized brine shrimp harvest for both birds and people. We're seeing success with the being able to manage salt content in Great Salt Lake through working together. I watched like the brine shrimp industry working with the state of Utah and actively collecting data and sharing information and writing papers together. And this really needs to be the new norm, that I think there's lots of places that have been doing that, and there's lots of places that can be doing that. And I think one that I can really point to right now is agriculture. Agriculture, the Bear River supplies 50% of the water into Great Salt Lake. Half of the water that goes into the lake comes from the Bear River. And man, we're gonna have to do some changing, right? We're gonna have to do like changing in cities. There's just more people. We need our farms though, right? We need our farms. Farms are open space and make this beautiful Cache Valley and like the Bear River. And we need to, I think we have this very urgent time that's gonna be like right now for a few years. We're in this drought. We've been diverting. But really like once we get out this drought, it won't be as so much of an emergency, right? And then we need to continue planning. So we don't have emergency measures in place right now to get wet water to Great Salt Lake. We couldn't just like turn a switch and say like, okay, this is going to be like we don't have that mechanism. We have some plans that I think are going to be really great, but they're like a couple years down the road. A lot of solutions are years down the road to even impact Great Salt Lake a little bit.
You see some of those being thrown in the back burner because we've got such great snow year. We think, oh, grass is over.
So I keep
Well, next year, who knows what's gonna happen?
I keep hearing like, oh, we just hope that it just keeps snowing, and I'm like, hope is not a plan. Like hope like is not a plan, and it's great, right? It's great. And we're going to get some more water, and the salt content has already gone down a little bit. Like we're out of that 19%, but it's not going to take one snow year. It's going to take like a decade of like getting more water to Great Salt Lake to turn it into something that's sustainable, that like we're not all on the edge of our seats thinking that like we're going to be breathing arsenic dust and that the economy is going to go to hell, and you know, all of those things. It'll take years.
Well, how crazy is it to that idea of bringing water from the Pacific?
So okay, well,
Is that
first,
just impossible or is so expensive?
it's like super expensive. We don't want salt water in Great Salt Lake either, right? So we'd have to pipe it here, desalinate it, and then put it into Great Salt Lake. And so I guess, I mean, like when you look at the scorecard from the strike team, I want to call them Thunder Force or something. Like I have these like the strike team. If you look at their scorecard, I mean, it's hugely expensive, and it'll take decades. I mean, think of like how hard it is to do anything in the environment. It doesn't just take one thing, right? I mean, decades of red tape. And so it's not that it's not feasible, it's that other things are more feasible, and that like we have that trigger point. I think conservation is the biggest thing, and not just turning the water off when you brush your teeth. Like this is like agriculture. This is, I mean, like from all parts. And I think, I mean, the way that I want to think about it is adaptive management in perpetuity, that we build policies that allow managers to adaptively manage, instead of just saying, hey, we have this like static thing, this one rule that we want, that rules within this like range of possibilities. I think are really, really, really important, and will help us be sustainable in the future, not just at Great Salt Lake, but the Bear River, right? We're this like interconnected ecosystem of people and water that need to work together. And so
70% of the water goes to alfalfa. Is that right?
yeah, I've heard that. And I wish, I think we need to get a handle on some of those numbers.
Mm-hmm.
Like, I think we need to get a handle on what's going on. Mm-hmm. And so a year and a half ago, we moved our family to Mount Sterling is where I live. And this is, I live on my husband's farm. It's a 5th generation farm. They have phenomenal rainbows during the springtime. This farm is 160 acres that was homesteaded by 5 generations ago. It's under a conservation easement and it's a dry farm. So I see all of these possibilities for like what farmers can do. The solutions need to be temporary, voluntary, and local. And I mean, I think that that's like a huge component of what is here.
Is Mount Sterling by Petersburg?
By what, Wellsville?
By Wells.
Yeah. Yeah. And this is, it used to be a dairy farm, so this is the holding pen. We live in the cow milking barn. This is like, I'm gonna turn this into a greenhouse back here. Like we have a pretty cool thing. But I moved up here and I realized I put a line in the sand in the Wellsville Mountains. And I was like, I'm not going to Salt Lake. I could spend all my time down there and I'm not doing that. I'm staying in Cache Valley. And I started going to like water district meetings. I've gone to watershed council meetings, like anything that I could like find in Cache Valley, I've been going to. And it turns out that not everybody is evil and just trying to take all of the water just to like take the water. I mean, there's parts of economy and, you know, money that go along with that. But it turns out there's this really like amazing group of people that are working on these up here. I also love baby goats. This is Nate. You got to go to Steep Mountain Farm is where Nate and Tara Steyerman, they have a little organic regenerative farm and I bug them all the time. Like I go over and I milk their goats and have like really kind of taken a head first dive into pretending to be a farmer. And I started pickling. And I learned that I measured it today, these are 5% salt content. So when you make your pickles, they're probably around 5%. So remember, south arm of Great Salt Lake is like 12 to 16%, north arm is 30%. Someday I'm gonna make Great Salt Lake water pickles this summer. And when I started doing all of this, I found myself going into these virtual meetings and I found myself really being, you know, in this place of like, man, the lake is dying. Like this place that I've studied for my entire career and that like I've put a lot of my heart and soul into. And it was pretty cool to start pickling and preserving and thinking about how maybe we're not so much in this pickle, right? Like maybe we're kind of preserving things and maybe, you know, we want this sustainable place that we can like have our Great Salt Lake and that we can have it sustainable and we don't get sick when we eat it and that it's preserved. I really loved that. And I always name my pickles silly things too. And so I think the biggest thing that really like we need, I guess the biggest thing that I don't want us to do is this. I don't want us, and I feel like we're on this trajectory of like building these solutions that are like passing on by each other and that are not working together. And imagine like how wonderful it would be if we could like connect, right? If we could put our energy into making that connection first and foremost. And it's hard, right? I'm like painted it to be an easy picture, like, oh, we'll just work together. That's what I don't want us to do. And I think right now we have this urgent time and we have this like opportunity to do what we did in the high years. Remember the pumps? Mm-hmm. We knew that the lake was like spilling its shores. It was causing economic damage. It was flooding farms. It was flooding businesses. It was wrecking roadways. And so we built this pump. We built this plant to take water out of Great Salt Lake and to put it into the West Desert, evaporate it, and then bring it back. This was this emergency measure that happened in the mid-1980s that we did because we couldn't do anything else. And I think, you know, I think we need to do that now. And, you know, another example is during that time, like this is State Street and this like kayaker, and I look at all of these sandbags. And, you know, we all came together. Everybody left their church and put their work clothes on And the governor called and said, hey, everybody come and put these sandbags out so that we don't ruin all of these like businesses. And we did. We all came out and we rolled our sleeves up and we put our work clothes on and our muck boots. And everybody came and built these places that could shepherd the water into Great Salt Lake. And I think that needs to happen now. First and foremost, emergency measures, get wet water in Great Salt Lake in the next couple of years. And while thinking about these longer range planning that are like land and water use planning and all of these buzzwords that you see, that actually the plans I think are really good. And, you know, we have this unique watershed, right? We have this 22,000 square miles that ends in a terminal basin. All of the memory of what happens or doesn't happen in that 22,000 square miles is held in this lake. And, you know, there's 85% of Utah that lives right next to Great Salt Lake. So I think we have this opportunity to work together. And I think, you know, we have this responsibility for all of Utah. And that's that. Thank you. Are there questions that are like, you didn't ask? This is a pelican from Gunnison Island. There's motion activated cameras on the island, and they do all sorts of really awesome things. But I love that sunset of this pelican. I imagine it watching a sunset.
Are they trying to keep people from tootling around on the lake bed on the off-road vehicles and breaking up the?
Yes. So last year, last year was kind of the year of Great Salt Lake at the legislature. I mean, they did everything from like appropriate tons of money. There were bills that changed like how we can think about like water and if it goes to beneficial use. Like there was lots and lots of things. One of them was extra money for monitoring the bed of the lake, because if people are out on ATVs, that breaks up that salt crust and makes it so that sand and that particulate matter can get whipped up with the wind easier. So yeah, but I mean 1,700 square miles. I mean the shoreline isn't 1,700 square miles, but it's pretty inaccessible and it's very remote. So that's a hard thing.
Hard to monitor.
Yeah.
If you're gonna talk, like talks like this, the education is the most important thing. Like I hear the most silly comments, like, well, why would we put drinking water in the lakes? Because the lakes dry up all the time. I'm just like, you don't understand, like it's an entire ecological disaster. Like, and then you can't tell from me like that. And
Yeah.
like, whatever.
Yeah.
You don't know what you're talking about.
Yeah.
Well, they need to look at the Emerald City. Yeah.
And I see there's some funny things, like there was, you know, the governor put a stop to like new water rights being appropriated on the Bear River. And there was a public meeting for that last week. I think it was last Wednesday. And I haven't watched the whole thing, but people are like, no, you're taking our water away. And I mean, actually, like nobody's taking anybody's water away. What they're saying is like, we can't have any more water. Like there's no more water, you know, I mean, we're going to come to this point where it's not just Great Salt Lake, right? If we keep like giving more water out and with all of these more people that we're getting, like we're still in that spot of someday somebody's going to have to come and say, no, actually, like if you take all of that water, this person downstream is not going to have that. And so there's no, like, nobody's taking anybody's water away. What they're saying is we can't give any more water rights. It's already, all of the water is spoken for. And Great Salt Lake doesn't even have any water rights right now. So I think, you know, this legislative session, people were pretty bummed out that one of the bills passed, that it was supposed to be a resolution for a minimum lake level. So that lake level couldn't like go any lower. That did not pass. That was squashed. There's still a bill that Casey Snyder put out that's talking about the salt content in the lake and how like we can manage the salt content in the lake. So he, you know, and elevation is related to salt content. And so they're really like thinking about that range of salt content that's going on. I think that is because of that Salinity Advisory Council and that salinity matrix, because there's like actual trigger points. Like with an elevation, you can measure the elevation, but it doesn't measure all of the other things with that, is I think the rationale. I think you need to think about elevation and salt content because of the dust and the microbialites, and that primary productivity. But it is, you know, I think that one's House Bill 244. I think that one's a good one that we might see pass in the next couple days. And the brine shrimp as the state crustacean better pass.
Well, I was up at Bear Lake last autumn on North Beach, and I noticed they're gonna be building homes along there. And I saw huge dust storms, because that lake is very, very low. I mean, I saw big gusts of dust. I thought, who in the world would want to live next to that and have all that dust blowing on their property and their houses? So even Bear Lake, I think, is going to be affected. They're drawing water out of there.
Well, I know Idaho's already taken steps to preserve their lake, so.
Yeah. Idaho's unique. Well, I think one of the big things that we have to do, so like even if we conserve water, like if I saved water, if I was a farmer and I saved all my water and said, send that 100,000 acre feet of water, whatever it is, down to Great Salt Lake, it might not make it there. So figuring out how to put conserved water into Great Salt Lake is one of those big things. So conserving the water and then getting it into the lake. And just, I mean, remember, there's like this emergency time right now for the next couple of years while we're recovering, if we're recovering, right? Like maybe next year we don't get any water, right? But, you know, I think we need to really like be conservative. I don't say that very often. We need to be very conservative in the next few years in getting water into the lake, and then continue to do these long-term planning and like optimization of agriculture and M&I use and all of those things.
Where does the water in Willard Bay come from?
It comes from the Bear River in one of those little like tributaries.
And that keeps it from going into the Great Salt.
Yes. It's my favorite. But yeah.
And who uses Willard Bay?
You know, like, I don't know much about it. I've been out on there with the Division of Wildlife Resources. And so there's lots of people that fish out there. There's lots of birds that do go out there, but it really was meant like as recreation.
Oh, just recreation. So it's not feeding Ogden or, okay.
No, I mean, they were trying to fix Great Salt Lake.
Oh, okay.
And make a freshwater lake out of it, because you can't boat on you can, but it's hard to boat on Great Salt Lake. It wrecks your boat. It's, you know, big and it's hard. And Willard, have you been on Willard?
I never have. I just drive by it.
It's really weird. Like you're on this boat, but you kind of feel like you're fenced in by this causeway, and it's kind of unnerving. I don't know. It's weird.
Why don't they let that water go?
Exactly.
Yeah.
I actually I think Bear River development needs to get gone. I think Bear River development really isn't good for anybody. Bear River development was made in like the 1990s when there was high water, there was different water levels. And I think it was disappointing this legislative session to hear that there was a bill that got stopped that was essentially like, there's still money going into Bear River development. And so they wanted to take that out and put that into Great Salt Lake work. And never did I ever think that I would hear any water district, because remember I came and like the water districts were evil and like I had heard all of this like bad stuff about them. But the Cache Water District, they just created a resolution through them saying that they reject the need for Bear River development. So I think that there's like support, not just from like hippies like me. I get called an enviro. That's what I call her out here, an enviro. Which is great. Like it's actually been one of the funnest things I get to do is like work with farmers I mean, I don't have a job. I'm a like feral mom. So I get to like work with people in like a little bit more open way. And I feel like that is there. The desire is there. I think there's not trust. And that trust is like hugely important. Like us enviros are going to have to trust these managers that like they're doing this thing that, you know, like closing the north arm of the lake seems like pretty counterintuitive, right? So I'm going to have some trust. And I think that there's going to have to be trust on the other side to like really work together. One idea, and I'll throw this out here and then I will stop. And I really, like my bio says I haven't shut up about Great Salt Lake since 1999. So you know that like I won't shut up. I think that trust is huge. And we just had a talk at Steep Mountain Farms with Steep Mountain Farm, not us. And Darren Perry, who's the former chairman of the Northwestern Band of the Shoshone that lives in Avon. He's, you know, my neighbor. He came and talked and there were some farmers there. One of the ideas is these farmers were like, hey, like we get this bad rap, right, for using all of this water, but there's actually some of us that really want to be friendly to Great Salt Lake, and how could we make a coalition to share information, to share just conversation. And so, you know, I've asked around, but if anybody has ideas about that, please talk to me after or email me at jaimibsalty@gmail.com, because that's something that I actually, like these farmers got really stoked about. And they came to me after, 3 different people came to me after and said, that's a really good idea. I want you to follow up on that. So, yeah, that's that.
Okay, well, thank you.
Yeah, thank you so much, Jaimi.
You bet.
Yeah. And I'm sure you might answer
Oh.
any questions.
Oh yeah, any.
I mean, just answer, just if people come up and.
Yeah, totally. And I'm gonna stop sharing so that not everybody hears whatever I say.